Okay, so again, we're gonna we looked at on Friday tangent line approximation and using it to find values on a curve that would be really hard to do, but I can do that with a tangent line sometimes easier, or a little without a calculator, or use it to find a zero, maybe a place where it crosses the x-axis, which I would normally not be able to find without a calculator. AP Calculus uses the former, especially. They use those questions on your test quite frequently. So definitely don't forget this. Don't forget to look over it if we have a quiz, which I think we have 2. And I think I'm done repeating that now. But today we are moving into a different direction, and it's a whole group of problems called optimization. This is one of the topics that shows up on the AP test. It doesn't show up a ton, but it is a big topic in Cal 1 in college. It's also a big topic when if you ever go into a business degree and you're taking a course on derivatives and analytics, where you're examining companies and you go in there and you analyze their profits or their losses. A lot of times you're going to be doing basically optimization. And optimization is essentially you want to find optimal conditions to operate. Okay, and we're going to use some dumb problems and some decent problems, but the whole idea of this is we want to find out where certain functions can be maximized or minimized. It might be a cost function, and I'm trying to minimize my cost. Right? So if I had a cost function and you want to minimize your cost, a lot of times these cost functions move like polynomials, and you're going to minimize them where the derivative is where? 0. So if you had a profit function, a cost function, and I took the derivative of it and set it equal to 0, like we've already done before to find critical numbers, I could find places where I actually minimized or maximized that cost function. And since I personally like to minimize costs, I would go and find out which of those costs was a min. And we know how to do that, right? We look at endpoints, we look at critical numbers, and we find whichever one is the lowest. Right? If I had a profit equation that talked about a company, and these are all the different ways I could maximize profits based on the number of people hired. Well, I might say, oh, if I hire up to 10 people, I can maximize profits here. But if I hire a few more, I might be able to maximize here. Well, we can analyze curves, and again, take the derivative, find critical numbers, and figure out where I can maximize profits, minimize costs. People do this, and we have a problem like this that we cover, like even in making boxes. Like, I don't know, I'm fascinated by sometimes the way they can take a piece of cardboard and hardly have any waste, and then cut it in certain ways and fold it all to get it all perfectly organized where it's really strong and compact. Or sometimes shoe boxes are like that. I'm not like super fascinated. I'm not like, oh my gosh, but like I pulled these boxes apart sometimes and laid them out, and I'm like, it's amazing how it just is a rectangular piece that's cut and engineered in a certain way where it really is strong and locks together, whatever. Well, a lot of that is, we're not going to get into some of the complexities of the engineered side of things, but a lot of that is, how can I maximize the volume and minimize the material? And those kind of things are maybe some simpler versions of what we're going to look at in here as well. Yeah?
I was gonna say, like, what's your favorite type of complex box? Like that was
I have a favorite.
Look, I like a nice round box. That takes a lot of skill.
I like a hat box. Yeah.
Yeah, that's pretty cool.
Okay, so we're going to be looking at those things, but there's a strategy for it. And I'm going to talk about how AP would give you points on certain problems. Now, in the olden days when there were no calculator problems, you'd see a lot more 9-point problems on optimization on your AP test. But since AP problems have evolved since the 70s and the 80s where there weren't any calculators, they allocate a lot of these problems to calculator use. And with calculator use, a lot of these, you kind of take the calculus out of it. Because if I had a calculator problem and I said, hey, where do I maximize? I can just graph it and look and see where it's at the max and find that Y value without using calculus. So what we're going to be doing is looking at a lot of this with the understanding that we probably aren't going to see this a ton on the AP test. On a heavy year, it might be 5 or 6 points. Sometimes it's only 2 or 3, but it does show up. But if you ever do take Cal 1 again in college, say you don't pass the AP test, or you say you want an easy A, you will revisit optimization. But what you need to learn is how to maximize your ability to get points. Because you're going to see on all of these, I'm going to give him points the exact same way. Like, did you write the derivative out? Did you say it was equal to 0? Did you find a certain equation? Did you find a secondary equation? Did you answer the question? Good night. I can't tell you how many times I'll say, hey, how many square inches of material do you need to maximize the volume of a box? And people go, the dimensions of the box are 12 times 5 times 7. I'm like, I didn't ask you for the dimensions. I said how many square inches. So make sure you're answering those questions. And if you have a really good format of show, or how did you know it was a max? Like that's a question that you're going to see all the time. If we're maximizing profit, how do you know that I'm maximized there? Well, what have we done to maximize things or determine maxes?
Determine if the slope is, or the derivative is 0.
Okay, that's the first thing, but that could be a min.
And plug in the original function.
Okay, so we use the extreme value theorem. We checked endpoints and critical numbers. Now, what if there are no endpoints? What if you've got a situation where I could maybe, obviously I have maybe a minimum amount of construction paper or cardboard I need, but what if there is no max? I mean, what if the domain basically is all reals? Then how do I determine a max? I mean, you've seen situations where, say you've done a number line analysis. Somebody's bouncing their leg big time.
No, I'd like to say he's working on it.
Very well, maybe that, yeah. You just see it's shaking. So let's just say you did a number line analysis and you found this. Is there a max? Now, if it's a polynomial, what do you know? You know that this is what? Going down forever. So there's no min, you know this is what? Going up forever. Now, if it's not a polynomial, and there's, say, a horizontal asymptote, then this thing could be following the horizontal asymptote, right? It's possible that it could be doing that. But you'd have to look at a situation, look at the problem, but this wouldn't have a max or a min, but it might have a relative max, right? So that might be my best hope of maximizing my profit. So you're going to have to use some intuition. Or if it had this, what do you know? There's two relatives, so maybe just check those two. You don't have to check every critical number in there if it's clear that this is not maximizing anything right here, right? So, but you can see that if I'm increasing, decreasing on the function, or if the slopes go positive to negative, on the derivative is positive and negative, you can see that they're relative maxes. Well, you can check both of those to determine which was the max of the two. Are you with me? So I'm going to walk you through the process. Don't forget this first page, because these are the things that you need to do when you get stuck. And this will kind of guide you through there. And I got to caution you, I'm giving you homework problems. You saw, I hate taking up homework. I really do. And some of you are like, yeah, he's not taking it up. I don't have to do it. If that's what just processed through your brain, that is a massive misconception. Go join the Peace Corps before you go to college, because you're going to learn in college from doing homework problems as well as being in class. And if you're not going to do homework, you're wasting your money. Yeah, you might check a box, but you're not learning anything. You know, go to some cheap college online if all you care about is a degree. Okay, if you really want to learn something, do these problems, because you're not going to have surprises on this test. If you do the homework problems, you're going to go, oh, I saw that, I saw that, I saw that. It's going to seem almost identical to what we've done. If you skip all the homework problems and you're an exceptional student, you might be okay. But you're rolling the dice on that one. Okay? So anyway, as we go through these, you're going to see me looking at these situations, and when you see me walking through these situations, if you can mirror this, and I'm going to do plenty over the next week or so, or whatever, how much time we have left, a bunch of these, and you're going to see the same thing over and over. The big thing is, can you look at these word problems and figure out what these equations are? And that's the struggle. And honestly, that has very little to do with calculus. That has your ability to recognize patterns, read, hear what the problem is saying, and come up with equations that represent it. But let's see what happens. So, first thing I want you to do is read the problem carefully. Okay? Read it carefully and identify quantities. Okay? If we're talking about a sheet of paper, and we're trying to create text on a page with certain margins, what kind of paper can I get all my words onto and minimize the cost of that paper? I might be talking about lengths and widths or whatever. Whatever I'm talking about, figure that out, and maybe even draw a great picture if that's going to help you. Okay? And think to yourself, what is this problem actually asking me to find? If you don't know the question, you're going to have a hard time answering that. Second thing, and this is where you really get going, write a primary equation for what's being maxed and min. minimize. If I said, for instance, I want you to maximize the volume that's necessary to blah, 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 well, then you should be thinking volume equation is my primary equation, because you're going to be taking a derivative of that equation, right? So if I'm asking you to maximize volume and I manage to give you a perimeter equation, don't take a derivative of the perimeter equation, or you're going to maximize the perimeter. Are you following me? So whatever it is you're trying to max or min, and sometimes I don't even use the word max and min. I use other things that allude to that. So slow down, read, whatever I'm maximizing, that's your primary equation. That's what you're ultimately going to be taking a derivative of. Okay? Now, let me ask you a question. On all the problems we've taken derivatives of so far, they've all been like y equals something with x's in them, right? Or maybe y equals something with t's. What if I have y equals something with x's and z's, or x's and y's? What if I have y equals something with a's and b's? That's too many variables for us right now. So you can actually do that. It's called implicit differentiation. We'll get there. But right now, I need you to get it in terms of one function with another variable. So when you set up that primary equation, what usually happens is you get something like area equals length and width. Length and width, too many variables. If I have something like volume equals length, width, height, too many variables. So what you're going to do is look for secondary equations, okay, that you can make substitutions with. And you take those equations, you solve for the variable you want to get rid of, and you plug them back into your primary equation. And again, if I'm talking too fast, I'm going to illustrate this through problems, okay? So eventually, you finally get down to like a y and an x equation. Maybe it's area, all in terms of length. Maybe it's volume, all in terms of width. And once you get it all in terms of one variable, now you're ready to go and take the derivative and maximize what you're trying to find. Okay? So you're going to see that a lot. But guys, you've got to identify that primary equation. And the primary equation is what you're going to be maximizing and minimizing. Every year I have somebody, it's really unfortunate because it's hard for me to give you credit on a maximizing volume problem when you have a perimeter equation that you're working with. It's just there's no points to give you. You know, it's like you've done a completely different assignment. All right? So, and then also think about feasible domain. What I mean by feasible domain is, do you know, have y'all ever seen Father of the Bride? No. It's an old movie with, it's a really old movie. Yes. Yes. Gosh, it really is old.
What's it about?
It's about this guy's daughter who got married, fell in love with another guy. It's a comedy with Steve Martin. But anyway, it's about just an exchange of like, she was like, the dad was like her favorite person in the world, and all of a sudden that shifted gears, obviously. She felt, and how he kind of lost it in the whole making of this wedding. Well, there was a scene in the wedding where he goes in there and he's losing it at this point because money is just getting funneled out of his account for this wedding. They're spending a fortune on it. And he goes in there and he's buying, this has very little to do with my analogy, but whatever. He's buying hot dogs for his hot dog buns, or vice versa. And you know hot dogs always come in the 6-pack, but the buns come in the 8-pack. I've always been one, I've wondered why they do that. But anyway, but he gets so angry, so he starts ripping off 2 of the hot dog buns and throwing them back on the shelf. He's like, I don't need these buns, I need 6. And bottom line is, there was some domain issues going with that. You can't buy, there's not an option to buy just 6 buns. Are you with me? Well, an implied domain suggests things like, hey, I don't have an option of this because the problem suggested that that wasn't in the cards. Like, for instance, if I'm buying notebooks and pencils, I can't buy a negative number of notebooks, or I can't buy a half a pencil. There's certain things in that problem that limit what I'm allowed to do. Are you with me on that? So if I only have a 24-foot wide sheet of paper, right, and I'm making a box, the biggest width I can have is 24 inches, right? Are you following me? So that would be my domain from 0 to 24. And even that might not be true because I might have to fold up the sides, right? I have a really tiny box if I only folded them up a millimeter, okay? So think about those domains as well, even though I might not give you just an interval and say, hey, the domain is 0 to 50. Sometimes it is implied in the problem and you have to learn from that as well. Because we need to know those domains when it comes to maxes and mins if I'm going to apply that extreme value theorem where I check endpoints. So all this is to say there's a lot going on these. You're not going to do well on these if you're trying to just get it done. Okay? Some of you might, but most of you are going to take a breath, slow down, and just walk your way through these problems. Think about these problems as you're doing them. And also understand you might not know where you're going. And sometimes you're going to get into some ugly algebra. But we're going to start talking about our calculators too and how we can use our calculator to do these. But today we're going to do the algebra side of things. So, and then also I said apply the extreme value theorem. If there isn't a feasible domain though, and you don't know what the max and the mins are, then you're probably going to have to do a number line analysis. Okay, and just actually check those. You can always do a number line analysis sometimes. Like if I did a number line analysis and I got that, there's probably a max right there, right? Or if I got this and that's it, well, there's probably a min there. Even though it's a relative min based on my rules, if it's coming down and then going back up, it's probably the min as well. Yeah?
Is this going to be a calculator test?
You'll have part calculator, part not calculator. Okay? At least that's the way I've planned it in the past. And by the way, at the end, remember, your goal is not to get an answer. Your goal is to show me the process. Your answer is going to be worth 1 out of 8 points. That's it. So if you're wrong, you can miss every single problem, but show me all the steps clearly and get 7s out of 8s all day long, or 9s out of 10s all day long. So again, if you don't have everything labeled and you're right on everything, and you just keep forgetting certain steps, you could be getting 6 out of 10s on everything, or 5 out of 10s. Bless you. Y'all with me? Okay. All right, so we're going to start basic with a couple loser problems that really would never happen in a whatever, but just to show you the idea of it. So right here it says, find 2 positive numbers where the sum of the first and twice the second is 100. The product of the 2 numbers is a maximum. All right, so I'm saying find 2 numbers that the sum of the first and the second is 100. The product is a max. So based on my rules, what was the very first thing that I suggested? Identify quantities to be determined and every other given quantity, okay? Draw a sketch if you think it might help you. Now, the second step is saying what? When you look at it. And that is whatever's being maximized or minimized. So right now, what am I trying to maximize or minimize here? The product of the 2. So if I set this up, I could say, okay, I'm maximizing the product. You could say P for product. And if you want, you could say, well, I don't know what the first number is, and I don't know what the second number is. So P equals XY if I want. Okay? Where X, you could say X is the first number. X is the first number. If you want to label it all, Y is the second number. Now, so far when we've taken a derivative, it's always been Y equals X. Well, now I have variable equals 2 variables. I don't function well with that, okay? I want 1 variable over here. So what I need to do is come up with a second. Does that make sense what I'm talking about?
Yeah.
I need to come up with a second equation that relates these so I can make a substitution. So do you know anything about X and Y that relates those two?
X was 2Y equals 100.
So it said the sum of the first and twice the second is 100. So if I look over here, I can get rid of that Y, or the X, doesn't matter, it's your call, by taking this and solving for 1 variable and replacing it. Now I like X here, because I'm kind of used to having X's and taking a derivative of X's. But if you want to have Y's, you can do that too. It might be easier the way I've set it up with Y, but I'm going to stick with X here. So I'm going to solve for Y by subtracting X and dividing by 2. And I'm going to replace this Y with that. So P equals X times 100 minus X over 2. Are y'all seeing that step? And this is like me now having Y equals nothing but X. Now if I had a calculator, and I'll show you this, I would just take the derivative just like it looks. But since we're doing this manual on this problem, I'm going to want to make this as easy as I possibly can for me taking a derivative. And I really don't want to do a giant product rule. So what I'm going to do before I do, this is just my preference, is I'm going to go ahead and multiply this out and write it out like a polynomial. I think it'll be easier that way for me. So how would I write P then? Maybe distribute it into the top. That would give me 100x minus x squared, all of it over 2. And then could I do anything to this before I take the derivative? Like gets me right back where I was. I could pull the 1/2 out front, or I could even divide 2 into both parts,
Yep.
and then it just looks like a polynomial. So again, this, if I had a calculator, I wouldn't worry about that. My calculator doesn't care what form is when you take the derivative. But right here, or when you graph the derivative, I'm going to divide the 2 into both of these, and I get 50x minus 1/2 x squared. So all of this is just to make me happy before I take the derivative. Now, here's how you'd be getting points so far. Did they identify the primary equation? Yes. Did you identify a secondary equation? Yes. Did you make a substitution? Yes. And for those of you who are like, what if I did all that in my head and I went straight to here? Well, I'd probably give you all 3 points if you were able to jump straight to there. Because sometimes you can, I understand. But if you want to take your time, do all 3, and if you mess that up, you'll still be getting credit for this. Okay? So, and then I'm going to clean it up. You probably won't get any credit for cleaning it up, but then you start getting credit for showing me your point. So if I'm trying to maximize P, then I want to take the derivative of the P to find out where its slopes are 0, because that's where maxes occur. Are you with me? Or maybe D and E. So I'm going to take the derivative of P. Now, if all I do right here is say P prime equals 0, you're getting an extra point because you're identifying that you knew that I needed to do that. And then you're also going to get an extra point for actually calculating the derivative. So at this point, you might be at +5. Then I solve this equation, and I find when x is 50, I have maximized my profit. Probably get a point for finding that x. Now, have I answered the question? It says find 2 numbers. Okay, now, before we get to that, technically, what I've done is found a critical number. I need to show that that critical number is a max or a min. It might be a min. That's not where I'd maximize this, right? It might be a min. So how can I do that?
Number line analysis.
Okay, I can do a number line analysis, and I might get lucky if it just does like this, which I'm guessing it probably will if there's just one critical number. Because if it's coming down on one side, right, or going up on one and down on the other, that's the only option for that relative max would have to be a max as well, wouldn't it? Is there a domain that I have here? Is it 0 to infinity if they're both positive? If they're positive, then the minimum it could possibly be is what? Technically 0. Now that's a little bit off because extreme value theorem says it would need to be on a closed interval. So it really can't be 0 and positive. What would the max be? It would be 100 if the y was a 0. So I can look at this and go, okay, really, I could technically check 0 and 100 and 50 in my original function, you following me? And treat it like an EBT. So this is one option. I could say, well, the profit, which is this function right here, I'm going to check the profit at 0, I'm going to check the profit at 100, and I'm going to check the profit at 50 and see where it's maximized. That would be one option. The other option is what George said, I think it was George, who said I could do a number line analysis. And he said, well, take your 50, even though AP won't let you, they won't look at this, they'll say check the derivative on either side. And so it's your call which numbers you use for the derivative. If you'd like to plug 49 in there, you can, but remember, it could really be any number. So if I plug a 49 there and a 49 there, I get what?
Positive.
Positive times a positive. I check the 49. If I check the 51 there and a 51 there, sorry, I'm checking the derivative. If I plug a 49 there, I get what? Positive. If I check a 51 there, I get a what?
Negative.
Negative. So I can see if it's going down in both directions, left and right, this relative max has also have to be the max. That makes sense, doesn't it? But if I checked all these values as well, if I plug a 0 in there, I get a 0. If I plug 100 in there, I get a 0 there. But if I plug a 50 in there, I get 50 times 100 minus 50, which is 50 times 25, which is what, 1250?
Sure.
Yes. Are you with me? So this is a great method when you don't have the endpoints of the regions, right? Because it tells you there is one, but I still would have to actually find the two positive numbers. So what is the maximum product? 1250. They didn't ask me that though. They said find the two positive numbers where the product was maximized. So what would be the two positive numbers? Okay, the x would be 50, and the y was 25. So those are the two positive numbers where you'd be maximized, and these conditions would all be met. And again, here's how the AP reader or me will go through there. Primary equation, secondary equation. Sometimes there might be a third equation too. Put them all together. Take the derivative, set it equal to 0 or D&E if necessary. Right? Find that critical number, and then check it with the endpoints or it with the number line analysis to determine where the max is, or if it even is a max, and then answer the question. And your last answer is probably only worth a point. Okay? So the one thing you would have to do on option 1 is to show this, but what you have to do on option 2 is to determine or explain this, because remember, the readers aren't allowed to look. So how would you determine that this was maximized here? What would you say? Can't say it. So you would either have to say f increased, then decreased on either side of x equal 50, or you could say something like f prime is greater than 0, or how about f prime changes from what? Positive to negative, changes from plus to minus at x equal 50. Either one of those two would be stating why you know that that's a relative max or whatever, and then answer the question. So again, 1, 2, 3, 4, the derivative, 5 for setting the derivative equal to 0, 6 for finding that, 7 for stating how you knew it was maximized, and 8 for finding the answer. And you're going to see these 8-point questions over and over and over. You skip this on every single one, you missed a point on every single one. You don't state the derivative equals 0 on every single one. I have this every year, no matter how many times I say it. You lost a point on every single one. Are you with me? You answer the wrong question, you miss another points. So it's either going to be really simple for you if you get this routine down, or you're going to make the same mistake a lot, which sadly some people do. All right, check out another one. What about this? A farmer plans to fence a rectangular pasture. Now this is like a real life situation, except that maybe the farmer doesn't know calculus. But like if you had some farmer sitting out there and he's trying to make a pen, this pen is obviously going to cost him money, right? He's got to put fencing up or whatever, and he's trying to maximize his pasture, right? But he wants to use the least amount of fence so he can minimize his cost. That's a real problem. I mean, some guys may just go up and go, fence it. But yeah, I don't know if you know this, but like there is a calculation that determines how many acres a horse or a cow needs of pasture land to survive. So you don't just throw cows out in the field and say, good luck. I mean, there's only so much grass that's growing, right? So you need a certain amount of acreage. So let's just say he goes, okay, I need that, but I want to fence it in. It might just work to run out there and make a square or a certain kind of rectangle, but you might end up using more fence than you need. So he's trying to minimize his cost, minimize the fencing, not to mention the labor and all that kind of stuff right here. So let's check it out and see if we can walk through this step by step and make sure we get all of these points if we can. So I got all these quantities I got to figure out, but what's my question? I'm looking for the dimensions, right? But what am I trying to maximize or minimize? So I'm minimizing fencing. Now think, how do you measure fencing? Do you measure fencing with area? What do you measure fencing with? Like perimeter, right? So it's the perimeter equation that I'm trying to minimize. This is a problem people miss all the time because they go, well, I need area. Well, I might want to minimize or maximize area, but it's the fence that I'm trying to save, right? Or use the least of. So I'm going to say fencing or perimeter. You let P equal perimeter. Okay, that's what I'm trying to minimize. Now, it says I've got no fences needed along the river. So you've got this river flowing, right? And I'm just putting fence there, there, and there. And it said it was rectangular. Okay? So if it's rectangular, and this is my river, and I don't need fence there, I guess the cows aren't going to swim away. Okay? So what are my dimensions here? What do you want to call them?
Length and width.
Want to call them length and width? I like X and Y because I'm more comfortable taking derivatives of X. So that's what I like, but you can use any variable you want. I would probably encourage you right now, until you get more comfortable with other stuff, of saying, all right, I'm going to call this X, which would make that X, and then maybe call that Y. So my perimeter, at least that I'm measuring, is what? 2x plus y. That's your primary equation. There's a plus 1. Problem is, I got two variables over here. So what else do you know about that figure? Do you know anything else?
X times y equals 180.
That's right. The area is 180,000 meters squared. And the area of this would be xy. That's my secondary equation. So I'm going to write, since area is length times width, or in this case, area is x times y, I'm going to say area, 180,000, is x times y. And that allows me to solve for the variable I don't want and replace it with the variable I do want. So, let's solve for y. And I'm going to replace that y, which is this, right here. So here we go. Parameter is 2x plus 180,000 over x. Y'all with me so far? So here we go. You so far have gotten a point for the primary equation, point for the secondary, point for a good substitution. So you might have up to 3 points at this point. Maybe 2, but whatever. Now, what do I want to do now? I want to take the derivative because I want the least amount, and least amounts occur at critical numbers, where mins or maxes occur. So I'm going to take the derivative of that. So what is the derivative of 2x? 2. How do you take a derivative of a fraction?
It's a negative. That's the power.
Okay, if you want to treat it like an x to the negative 1 and do a power rule, great. If you want to do L'Hopital's, which I don't mind at all because I'd rather not have negative exponent, not L'Hopital's. If you want to do the quotient rule, check it out. What's low, d high? 0, so I'm not going to write anything. Minus high, d low.
Negative.
So just times 1, right? Over low squared. So I like doing that, but if you want to treat it like an x to the negative 1 and go negative 180,000 x to the negative 2, same difference. Then take the x to the negative 2, bring it down much. Now, that's the derivative, but what am I trying to do? Set it equal to 0. If you set it equal to 0, you've got a plus 1 for calculating the derivative correctly, plus 1 for stating you knew that I was setting it equal to 0. And now you're at plus 5. You're at plus 4, even if you took the derivative incorrectly, because at least you did all your steps. Now, how do I solve this equation? What would you do? Don't make it harder than this. What would you do if you were given 2 plus that equals 0? Move over the 2. Okay, so now you have negative 180,000 x squared equals negative 2. Then what would you do? Multiply by an x squared. If I do that, the x squared cancels on the left, and you have negative 180,000 equals negative 2x squared. Divide by negative 2 gives you 90,000. And then what? Square root it, and usually these numbers work out nicely if it's not a calculator, and that would give you a 3 with 2 zeros. Right? And you square it both sides. Technically it's plus or minus, but can you have a negative amount of fencing?
No.
Okay, so 300. Now, that would be a point to you. Now you're up to plus 6. But do you even know if it's minimized or whatever there?
No.
So how do I check that?
Number line analysis.
Okay, so option 1 would be the extreme value theorem. Option 2 would be a number line analysis. Now, again, the extreme value theorem I really like if I can find endpoints. I can't find do you have any endpoints for your x's?
0?
Definitely 0 would be a minimum, right? I don't want a fence that's like 0 width and a zillion miles long, but if you start thinking about it, this right here, if x approaches 0, what's y going to approach? If you think back to this original problem, if x approaches 0, y is going to approach even bigger. It's going to approach infinity, isn't it? Are you with me? Think about this graph. If I divide by x, what does a y equal 1 over x graph look like? It looks like this. What do you think a y equals 180,000 over x looks like? Pretty similar, right? Point is, as one approaches 0, the other one might be approaching infinity. As one approaches infinity, the other one might be approaching 0. I'm not going to find endpoints on that. So for me, not going to have any luck with my implied domain there. I'm going to go over here. Number line analysis, though. I've got a point, 300. Let's check the derivative on either side. Say, it doesn't matter, 290 and 310. Here's my derivative. We know that 300, right? 300 right there gives me 90,000. And negative 180 over 90,000 is negative 2. That's why that became a 0. So what do you think 290 gives me? If 300 gave me 90,000, what does 290 give me? Less than 90,000. What do you think that over less than 90,000 is? Bigger than a negative, I mean, well, a more negative number. And a 2 plus an even bigger, I guess smaller technically, negative 2 point something would be negative. And then if 300 gives me 900,000, which is a negative 2, then 310 would give me bigger than 900,000, which would make that smaller than a negative 2. Are you tracking with me? Which makes that positive. And again, you can see that is minimized. There. Now, you'd have to explain yourself. So how do I explain this? What would I say?
F prime is decreasing, 300 and increasing actually.
F is,
Oh, yeah.
but you'd say F prime goes from negative to positive at x equals 300. And it's probably better to talk in terms of the derivative because it's calculus class, right?
Do we need to, like, what makes sense if we call that F prime or we need to call it P prime?
Oh, no, you're absolutely right. Absolutely right. Yeah, that's a great point. I'm getting sloppy there out of habit. If you call this P, then call this P. And if you want to avoid that kind of mistake I'm just making, technically you could say, let F be the perimeter just so your habits don't have to change. Are you following me? Because I do that all the time, and that is important. It's really important, actually. On your AP test, if you go around talking about F because you're in your happy place, but the function's P or A or V or whatever, the reader's going to go, what are you talking about? They're not going to go, oh, little Johnny's so sweet and babysits my kids, I'll give him the benefit of the doubt. It doesn't work that way. You really have to be clear, and that's poor on my part.
So would we have to put length and width for the x and y, the whole time just at the end?
As long as you label it, you're pretty good. Like if I can say x and y, they're not going to give you a point for calling that width and calling that length, as long as at the end you answer the question correctly. Are you with me?
But you do need to label the P.
Again, you can call it anything you want. I can call that P if you want. I can call that F if you want. As long as you're consistent all the way through, you're okay.
Do you only need to label the overarching one like the P instead of the x and y?
You don't even have to do that. Is this what you're asking? You can call that F of x if you want. If you want, you can call it function F.
Did I need to say that F equals perimeter?
No, as long as you're consistent all the way through this problem. It's not going to hurt you. It certainly helps the reader understand what you're doing. But as long as you're consistent and you don't get to hear and go, L equals something, W equals something, and they're going to look back and go, what's L and W? As long as you go X is this and Y is that, when you're answering the question, you're fine. Or P is this, you're fine. So again, you got an answer for that. You got a point for explaining this, okay? Because you've already said the derivative is 0. You've already said that. You can repeat that if you want, but you've already stated that. And then the final thing is, can you answer the question? So they didn't ask you what the least amount of fencing was. Don't tell me that. I don't need to know that. What do I want? What the dimensions are. So what are my dimensions? X is 300 And really, you can just write them like dimensions. 300, we talking about feet? Meters, 300 meters by, and then how do I find the other one? Plug it in for x there, and that gives me what? 600. So 300 meters by 600 meters would be fine. And if you want to say x is 300, y is 600, that's fine too. Are you getting the idea right here? Guys, you can't miss little steps. This is so robotic once you get used to it. Now, you're going to see problems where you go, how am I supposed to think through this? Like, this was really hard to set up. And some of them are. They're really hard to set up. But if you see them all in your homework, my hope is that you go, oh, well, it's the same kind of thing on the test. If you do not do homework problems, you're going to see some problems in the test where you go, whoa, that's tricky. But if you do the homework problems, you shouldn't be surprised by stuff. So you're really kind of, when you study, if you understand the process, you're just studying, am I ready to set these certain problems up? All right, what about this one? Design an open box with a square base. So square base, sometimes they'll say rectangular. This one clearly said square. And a surface area of 108 inches. Now they notice they said open box, so there's no lid on it. And I'm designing it out of a giant piece of, so it says what dimensions will produce the greatest volume. So let's get a feel for this. So if I'm designing a box, all I know right now is the surface area, and we know what surface area is, right? Area of the bottom plus the areas of the sides, since it's open, there's nothing on the top. So if I'm designing this box, and I want it to have it says make the volume maximized based on that surface area, what is your primary equation? Or what am I trying to do here? Maximize volume? So by maximizing volume, what's volume of a box like this?
Or just being square on side because it's a square base.
So you can do L, W, and H if you want. I don't have a problem with that. But again, I kind of like having X, Y, Z, or I like having X in there. So, but I do know that the bottom of this is what?
X squared Y.
Yeah, they said the base was square. And then you got a height coming off of that. So if it were me, I would call this bottom X, and then maybe call the height Y, and then look to get rid of that Y. If you called the bottom Y squared, that's fine, but again, I like having the X's left, so I kind of set the problem up with that in mind. So my volume is X times Y. And right there, there's my basic equation, my primary equation. Now what else do I know?
Surface area is 108 inches squared.
So that might give me a chance to get rid of this Y. So surface area is the sum of all the areas of the sides. So how would I find the area of all these sides?
4 times XY.
Does that make sense to everybody? If each of these has a base of X and a height of Y, you have 1, 2, 3, 4 of those. So 4 XY's plus a what? Plus an X squared. And all of that equals 108? Yes, no? Can you see maybe what a primary equation would be? I mean, a feasible domain would be? It's going to be tough, isn't it? I guess I could think like this. If Y was 0, X could be what? Those two things would have to add to give me 108. I don't feel like I'm getting very, very many places here with a feasible domain. And if I can't see a feasible domain easily, I'm like, screw that. I'm just going to go and find the critical numbers and check to see if it's a relative max or relative min. To me, it'd be easier to do that than try to determine what those domains are, because that's just, to me, kind of tricky.
For the surface area, would we do the surface area of the inside and the outside of the box?
No. Just surface area would be just like whatever the areas of these. We're kind of pretending like there's no width to the box, even though I know it would have a little bit of width. So yeah, like the surface area of a cube is just the area of the faces. But I don't do the area of the top face because it's an open box. Does that make sense? So I wouldn't want to go, is that what you're saying? I wouldn't want to go times 8.
So like there's the inside of the box on the bottom, and there's like the underside area also. Does that just...
No, don't overthink it. Just think like you did in geometry. So if I'm doing any kind of surface area of anything, just think if I were to cut this and open it up and lay it out, what would the area be? Okay, so right here, what would be easy to solve for? Well, if I solve for x squared here, my x's are going to be on the other side. So I'm going to pick the variable that's the easiest to solve for. There's only one y. So and that may be what you meant, but I'm going to leave that y there, subtract the x squared over, and divide the 4x. And that gets a nice, neat version. Well, it's not that neat, but it gives me some version of y that I can now substitute in here. So here's my substitution. By the way, I would get a point for this setup over here, and a point for probably plugging this in correctly. So at this point, we're probably at a +3. The minimum a +2. And here's my question for you now, before the bell rings. Would you do a product rule here, or would you probably try to clean it up a little bit? I'd probably just cancel one of those x's out, and then distribute that x into the top, maybe divide everything by 4, and I'd have a better looking polynomial. So I don't have time to finish, but hey, third period, has everybody signed up for, I sent y'all a message. If you haven't yet, how did you get your code? Was it there? Oh, I sent it the second time, that's right. I'm losing my mind. Hey guys, make sure you do this, okay? Make sure that you're signing up. I sent you the one to tell you to do it, and then the second one with the code on it.